Okay, so we have this excitation source here, Vi of t, and here we have an inductor indicated by L, and this is a resistor. Okay, and the voltage across resistor that is to be measured is indicated by VO of t. All right, and obviously there is a loop current I of t. So let's define it. Let's try to obtain the frequency response of this network. So what is the impedance? Impedance would be Z, because it's a complex variable here. So we can always also write Z of S. S is a complex variable. All right. So this is another form. So impedance would be obviously the resistance impedance would be the voltage divided by the current, and it can be written as R plus L of S. So we can always write Vi of S into I of S would be Z of S. It's nothing but R plus LS. So we can write Vi of S, that is I of S. This is S actually. Into R plus LS. And so that's our equation. And if you want to get the current, it would be voltage divided by this impedance. And we can always also write VO of S, that equals I of S times R, because that's the current that flows through the resistance multiplied by the value of the resistance. So how to write the gain expression for the gain? It would be VO of S divided by Vi of S, which is I of S times R, I of S R plus LS. If the S is 0, then we have this voltage gain is equal to 0. Voltage gain will become 1. All right. So that prompts the response of the so is the frequency is 0, S equal to 0, so voltage gain will become equal to 1. So that prompts this circuit exhibits the response of low pass filter. For the case of S equal to infinity, when S tends to infinity, we have this the gain becomes 0 actually. All right, so that is prompting the response of a low pass filter. So let's call this as equation number 1 and put S equal to j omega in equation 1. So what we have here is this equation, that is the gain of this network as a function of frequency, all right, would be written as R divided by L j omega plus R, which can further be written as, we divide the numerator and denominator by R, which would be L by R j omega plus 1, and that comes out to be, we can always see that it can be written as omega over omega L plus 1. So what we see here is the time constant for this network is L by R. So the frequency, cutoff frequency would be 1 over tau, that is R over L. All right. So we can always write this expression in this way. So with this done, we take the magnitude for this network. It will be whole square, and the angle or the phase can be written as tan inverse omega by omega L. Right? So we take the three cases for, let's say, omega that equals to 0. We see that the magnitude, we can define it like the gain now. Okay. So what we define here is the gain of this network that comes out to be 1 for omega is equal to 0. So we put the value of omega in this equation and in this equation, and we evaluate, calculate what is the gain and angle. So we call it as the phase now. This is our phase. Okay. So gain comes out to be 1, and angle phi is that is tan inverse of 0, that comes out to be 0. For omega that equals omega L, magnitude takes the form of 0.707. Why? Because this factor becomes 1 over here, okay, and 1 by root 2 is 0.707, and phi becomes tan inverse of 1, that is 45. And for omega that equals infinity, the gain is 0, and phi is actually can be written as 90 degree. All right. And this characteristics that we can plot is can be written as this one. We have the gain at omega is equal to 0 of 1, and then we have this somewhere at omega equal to omega L, we have the value of 0.707. All right, it is called as minus 3 dB point, and this frequency is called as minus 3 dB frequency. And finally, we have omega tends to infinity. So we have this function that is going towards 0. Similarly, for the phase, we have this value. Let's say we have a 0 degree at omega tends to 0. At omega is equal to omega L. What we see here, we approach the value of 45 degree. All right, and we towards the infinity. So this is how we get is the 90 degree. All right, this is not a minus actually. We can this is plus. So this is the characteristics of a low pass filtering action. All right.